So to kind of show you that, I want to show you a second demo that gives you a little bit more insight into what I'm talking about inside of these services. So the second demo is also running a couple of Akka microservices in Amazon in Kubernetes. And this is exactly what the other demo is doing that I just showed you, the map demo that I call Where on Earth, but it's doing it at a much smaller scale. So what this represents here is a running single microservice. And it's kind of showing the inside of these single microservices. So the three big circles represent three pods, three nodes in an Akka cluster. So a node in an Akka cluster is a JVM. In Kubernetes, a JVM runs in a container, a Docker container. The Docker container runs in a Kubernetes pod. So it's kind of a, JVM is in a container, containers in a pod, pods run in Kubernetes. So it's like running three JVMs on three different virtual machines, for example. So that's what these big circles represent. They also represent HTTP endpoints where there's HTTP traffic coming in from the top right here. So these lines coming in from the top right are live HTTP requests that are being fed in through another simulator into this microservice example. And then the lines you can see are coming into a individual JVMs here, nodes in a cluster. And I can turn off some of these lines so it's not kind of a scramble. So we're just seeing the kind of the message tracing that's coming into one of these nodes in the cluster. So the reason I wanted these lines to come in, these are HTTP requests coming in from the top right into this node circle. And then the lines coming out of it are going to these circles on the perimeter. And these are the stateful persistent objects called entities. These entities are the place where your business logic runs. So, say if this was a shopping cart application, these entities would have the business logic. It's just a class. It's an instance of a class. That's why I call it an object. These classes are getting, incoming requests through a method, and those requests are things like add item to cart, remove item from cart, change the quantity of an item in the cart. That type of thing. That's what these things do. But these entities are instantiated across a cluster. The HTTP messages coming in to this one HTTP endpoint are then routed across the cluster to specific entities, because these requests are coming in are for specific entities. So that the routing is being handled by Akka here. This is what allows us to make these entities stateful. Meaning that when an entity receives a message, if it's not instantiated, the system instantiates it and it populates it with its data. Now the entity is stateful. It doesn't have to read from the database anymore. It's got its state in memory. And every time it receives subsequent messages after that, it's going to not have to in a stateless system, and I'll show you this towards the end of the presentation, but in a stateless system, you constantly have to reread the state from the database, bring it into memory, do your computations, and push your changes back down to the database. In this approach, because it's stateful, we're eliminating having to constantly reread the data from the database. And the trick to this whole thing is this ability to route messages to specific entities across the cluster. Now, one of the things I want to show you though is to show you what happens when a failure occurs. So say I'm highlighted just these entities here, and I highlighted by clicking one of these green circles, and these green circles are called shards, and they're also these are Akka actors if you're familiar with Akka and the actor model. But these shards are used to distribute load across the cluster. That's what their job is. So what I'm going to do is I'm going to stop this node in the cluster, this node 76, and I'll show you what happens when a failure occurs. So I can stop it by clicking on it up in the top left. So now we're down to two nodes, and then what we should see in a moment here is there's the red shard. the red shard, Akka saw that we lost the node in the cluster. We're still receiving messages for these entities that belong to the shard. Well, Akka brought that shard back to life in another node in the cluster. Now, while I was talking, Kubernetes saw that one of the nodes stopped in the cluster and it restarted it. This is what Kubernetes does. So this is kind of the reason for this demo is to kind of show you the relationship between Akka and Kubernetes here. Kubernetes is handling things kind of at the pod JVM level. You know, it's kind of at the coarse grain. If the process stops, if the JVM stops, if the container stops, if the pod stops, you know, that whole containerization that happens within a pod. When one of those instances stop and you've told Kubernetes, hey, I want to run 3 of these things, it will react to that and start things up at a coarse grain level. It'll restart the process. At a fine grain level, inside of those processes is what Akka is handling. So it's handling the management and the distribution of individual entities across the cluster. So that's kind of the mechanics. The other thing I do, if given more time, but I think for the sake of time I won't do that here, is I show scaling up. Simulating. I can simulate increasing traffic and then increasing the number of pods at the Kubernetes level, and then showing how the workload gets of these entity actors gets redistributed across the cluster. But also, again, this demo is, the source code is available, the JavaScript, the Java, everything's available. The READMEs are there to help you with the installation and setup of these demos. So, if you want to try it yourself, I'll give you the links at the end of the talk.